All right, so 2-4 deals with, as I said, complex numbers. And you're going to want a highlighter. Complex numbers involve the set of imaginary numbers along with a set of real numbers. So I just want to alert yourself to the fact that this is what you learned in Algebra 3-4. We can't take the square root of a negative number, right? So somebody got bored and decided, let's take the square root of a negative number. And they did. So they said, let's let the square root of -1 be I. We're imaginary, doesn't exist. And then if we took, what's the square root of -1 times the square root of -1? Whenever you take a square root and multiply it by itself, what do you get? The number underneath the radical. And so that's why I squared becomes -1. So then you can continue and keep going. I cubed, I to the 4th, I to the 5th. Like I cubed would be I times I squared, wouldn't it? So what's the square root of 1 times -1? Negative square root of -1, which would be -I. So I cubed is equal to I times I squared, which is -I. It's typically how we'll look at it. Or negative the square root of -1. And then I to the 4th, I'll do one more. I to the 4th would best be multiplied as I squared times I squared. So what's I squared represent? -1. So what's a -1 times a -1? 1. So I to the 4th is 1. And then it starts to repeat from there. So couldn't I take I to the 4th and multiply it by I? What do I get? What's I times, what's I to the 4th, which is 1 times I? What's 1 times I? Just I, right? And so it starts to repeat itself. And so if you could get to the first 4, then they all tend to repeat from there in various patterns. So we'll use all that in a minute. Complex numbers have imaginary numbers in them. So here's your standard form. We have a combination of real and imaginary. So notice that A is your real number part and B is your imaginary number part. So you're going to have something like possibly 5 plus 3i, or -4 plus 2i, or -6 minus I. Whatever part has the I in it, that's your imaginary part. Whatever part doesn't have the I in it, that's your real part. The real part has to come before the imaginary part. Think what came first, real or imaginary? Real. Then pure imaginary would be just something with an I in it. Nothing being added to or subtracted from it. So it would look like 3i or -2i. You wouldn't have anything in front of it. Then we're really not going to do anything with example 1, but it's called an identity if and only if A and C are exactly equal and B and D are exactly equal. So the left side equals the right side, that's going to be called an identity, right? Now we're going to add and subtract. Pretty simple. What's, add your real part together, add your imaginary part together. So what's 3 plus 7? 10. And then I plus 3i. So we get 10. What's I plus 3i? 4. Plus 4i. Do I expect you to show what I just wrote in between? No. But these are your notes, right? And then what do you have to remember to do with subtraction? Add the opposite, distribute the negative, change the signs, right? We don't change the signs of the what comes in front, only what comes after. So plus a negative and a positive. So then I end up adding the 4 and a -10. And I add an I and a positive 2i. So what's a 4 and a -10? -6, I and 2i, 3i. That's a review, isn't it? Okay. So then let's go down to multiplying. And again, remember that I squared is -1. Isn't it wonderful? If only all of our classes could be this tiny. We would get so much more done. That's right.
Thank you.
You're welcome. Yeah, but can you imagine if you're a freshman class and you didn't get along with everybody in the class? See, the older you get, the better you get along with people, and the more accepting you are of others, right? Whereas freshmen aren't quite there yet. Oh, there we go.
But see, that's why I liked having you freshman year, first period, because my excuse for not talking to people was I was too tired to be social.
There you go. But now you're not too tired to be social.
Yeah.
All right, so now we're going to multiply. What's 5 times 2i? 10i. Done. Right? And then what's 3 times 6? 18. I times I. Now you cannot leave an I squared because we know what I squared is. What's I squared? Negative 1. So for your note purposes, I want you to write in there that you've replaced I squared with a negative 1, because otherwise you won't remember why. I'm not crazy. That does look fuzzy, right? Yeah, I know, I am. There, that's better. All right, so then your final answer is negative 18. If you give me an answer with an I squared in it, if you give me an answer with anything but an I, if it's I squared, I cubed, I to the 4th, I to the 5th, you will get it wrong. So you can only leave an I in your answer. All right, so what's 7 times 6? 42. And then I to the 3rd times I to the 4th. I to the 7th. So then we're going to split this up. If I were you, I would split it up as I to the 6th times I. And the reason I would always split it up into an even exponent, just pull out one I, because I to the 6th can be I squared, I squared, I squared, and then our I. Now, you're not obviously going to write all that out, but I'm just explaining why it is what it is. What's I squared? Negative 1. So we really have negative 1 times negative 1 times negative 1 times I. What are 3 negatives? Negative. So isn't our final answer negative 42i? So I to the 6th is negative 1. But what's I to the 4th? 1. Positive 1. What would be I to the 8th? Positive 1. So every even exponent, it alternates. Positive 1, negative 1, positive 1, negative 1. So you can't assume that every even exponent's a negative 1 or every even exponent's a positive 1. You have to think about it. So consider how many pairs of 2's you can pull out of there. If it's an even pairs of 2's, and I could only take out 3 pairs of 2's from I to the 6th, then that's an odd number. You're going to have a negative. All right, so then what do you think we do there? FOIL. Yay. So here's what I do when I FOIL. I'm going to line up what are like terms. So 3 times 7 is 21. 3 times negative 4i is negative 12i. Then distribute the second one. 2i times 7 is positive 14i. I'm going to put it right below. And then 2i times negative 4i is negative 8i squared. You'll start to learn that an I squared changes the sign, right? If you don't remember that from Algebra 3-4. So I get 21. Adding like terms, you don't change the I. So you have a negative 12 and a positive 14 gives you positive 2i. And then doesn't this negative 8i squared change to a positive 8? Mm-hmm. And that's because I squared is a negative 1. Negative 1 times a negative 8 is a positive 8. And then your final answer would be 29 plus 2i. And notice that I am writing the real part in front of the imaginary part. You have to get in the habit of writing it in standard form. Now the last one, don't trip yourself up on. Do not do negative 4 times negative 16. What is negative 4 times negative 16? Positive 64. What's the square root of positive 64? 8. That's not the answer. So instead, we're going to take the square root of 4. What's the square root of 4? 2. So it's really 2 times the square root of negative 1, isn't it? What's the square root of negative 1? I. So the square root of negative 4 is 2i, and hopefully you learned that in 3-4. Then times, what's the square root of negative 16? 4i, right? And then what's 2i times 4i? 8i squared. And so what does I squared do to the 8? Negative 8. Do you see why if we multiplied these two together we would have had a positive 8? And the answer really should be a negative 8. Stop looking at right. All right, then let's divide. Do you remember how to divide? Remember what to do? What do? You have to actually multiply by something.
1 minus
The conjugate.
The conjugate, you're very good. What's the conjugate of just the denominator, remember? 1 minus 2i, so only the middle sign changes. So we're going to multiply top by 1 minus 2i and the bottom by 1 minus 2i. And you might want to write yourself a note, I'm going to put parentheses around this, that this is the conjugate. Because I might ask you, what's the conjugate? And if you don't remember what that is, because you didn't write it down, you'll be in trouble. Now distribute the 3 into the numerator to get 3, whoops, not a plus, 3 minus 6i. And then what is the beauty of the conjugate? You get rid of the middle term because what factor pattern is this? Difference of two squares. So if this is a plus b times a minus b, doesn't it multiply out as a squared minus b squared? So take your first term and square it. 1 squared is 1, minus, always a minus. And what's 2i squared? 4i squared. Now if you want to FOIL it and have your inner and outer term should cancel out, feel free to do that. Alright, so then keep going. We have 3 minus 6i over, what does the I squared do to the 4? Changes it to positive. And so then I have 3 minus 6i all over 5. You can't leave it that way. That's not proper standard form. So you have to, if the whole thing is divided by 5, can't I break it up and say 3/5 minus 6i over 5? This is proper standard form. Does that make sense? If you give it to me this way, you're going to lose points. Only because we're going to do something with those later. So then, why don't you do this one on your own? Multiply by the conjugate. Whoopsie. When you're done, compare yours with what's up front. How'd you do? Are we good? Any questions on what I have and why? Okay. All right, so that's probably one of the harder things for you to do is the conjugate. You had that in Algebra 1-2 and in Algebra 3-4. Remember the conjugates in Algebra 1-2? What context did you use them in? When you had something in the denominator. A radical, a square root. And technically here, don't we have a radical in the denominator with an I there? And that's why you have to multiply by the conjugate. And so notice that we no longer in either of these two denominators have a radical in the denominator, and that was the whole purpose of your conjugate. All right, last thing. We are going to plot points. So long as you know where the imaginary axis is and the real axis, you'll be fine. It's just like plotting a regular ordered pair. So this is I. In other words, this is our imaginary axis. And then this is, we'll do double R. And doesn't double R mean real numbers? So this is the real axis. So X is your real, and in standard form, real comes first, and Y is your imaginary, and in standard form, imaginary comes second. So alphabetically, X comes before Y. And then in standard form, real comes before imaginary. So if that helps you remember it, then put in some hash marks. All right, so we're going to plot these points A, B, and C right here. So to plot A, isn't the real part 4? So go to the right 4 from the origin. And the imaginary part is a positive 3i, so you would go up to 3. So this is 3i, and this represents A. So that would be in the quadrant 1, which is your positive quadrant. What quadrant is this one going to end up in? Which is which quadrant? 3. And so we're going to go to the left 2, and then because the 2i is negative, we're going to go down 2. So this right here is point B. And then C, if there's no real part, what does that mean? Yeah, it's on the y-axis. We don't go right or left. So because it's a positive 3i, you're going to plot a point on the y-axis at 3, and this represents point C. That's not difficult, is it? That's it.
You just connect them.
You do not connect them. Thank you for asking. All right, any other questions? You like that homework much better than the previous section, don't you?